Now, if you want, you can zoom it. It's enough? Okay. In the earlier lecture, we discussed three problems. Do you remember in part 2? What was that three problems? Regarding normal distribution. You need not tell all the details of the problem. And those who attended that lecture, they are clear that this problem is not among them. It's a very different problem. And I appreciate this problem because, and also you will appreciate this problem because it's giving a sense of real world problem. What is that saying here? In a test of 2000 electric bulbs, what is the way how they conducted that test? That is all not needed for us. What is required is they have conducted a test, they have come to a conclusion that 2000 electric, that bulbs are having burning time how much? Average life of 2040 hours and standard deviation of 60 hours. What is the meaning up to here? You leave about all these things. What idea you got up to here? 2040 hours is the means generally that bulb will glow up to that many hours. But it is not that exactly 2040 hours finished, the next day it is off. Not like that. Sometimes it will glow some more hours, sometimes it will glow less hours. So there will be some standard deviation. And what is the standard deviation? 60 hours. And that too, one thing more, there is no need of telling that in a test of 2000 electric bulbs it was found that. By a test it was found. Actually, the framing of the question is not proper. Why I say? That is, 2000 electric bulbs are given here, and finally that fellow is asking like this: estimate the number of bulbs likely to burn for more than this many hours. Means how many of the bulbs you expect to what is that? Glow or what? Burn for more than 2150 hours. What is the average life? 2040. Means how much more hours you are expecting? 2150 means 110 hours you are expecting. And standard deviation is 60 hours means, okay, up to that time you have some probability, good probability. But you are expecting more than that. So what is the probability that it will glow or burn for more than, not exactly 2150 hours. It is more than 2150 hours. Got my point? Similarly, second, third bits should be understood. It is less than 1950. And it is saying the interval that it should glow more than 1920 hours and less than 2160 hours. I hope you got the idea of the problem. What is the technical fault in the problem? That is, this wording, estimate the number of bulbs, that number can be decided if we know the probability and we multiply it to the total number of bulbs available. Yes? So, how many are available? 2000 are available. But what is the wording here? In a test of 2000 electric bulbs. Means it is like asking, test is getting conducted. One meaning. Another meaning is that test was conducted and this was the average life and this is the standard deviation. It is not clear whether that test is that test which is already conducted and decided the mean and standard deviation, or it is asking about the test which is going to be conducted and then we are talking about how many bulbs will glow. So that is not the fair way of asking the question, even though it's a very standard book. That is the question from Dr. B.S. Grewal. And I'm commenting on that. I don't know what people will think about it. But I'm justifying my point. I hope you are understood. So let us assume that test was conducted and these figures have come. What is that? 2040 and 60. Mean is 2040 and standard deviation is 60 hours. If we have a lot of 2000 electric bulbs with us and we are installing them, that all the 2000 electric bulbs we are installing in some institution or some infrastructure somewhere, in some building, then we have some chance that some bulbs will glow for more than 2150 hours. What is the probability of a bulb burning for more than 2150 hours? If you know, with that probability we will multiply 2000, then we will come to know how many bulbs will glow for more than 2150 hours. I hope you got my point. So what are the two stages in the problem? Number one, finding the probability for a random bulb to glow random bulb. That random bulb is satisfying normal distribution. So how will be the situation now? Is there any chance that after only 2 hours the bulb goes away? Is there any chance or not? But do you expect that it is having good probability? No. So it's having very low probability that it will burn only for 1 hour, 2 hours, 3 hours. So what happens? The curve grows like this. So when it comes near to 2040, then it will go up. And finally it starts going down. Got my point? And what is the standard deviation? 60 hours. So we expect many bulbs to glow up to on an average of 20-40 hours. If the question is understood properly, then 50% of the solution is understood. If 5000 bulbs are planted, installed in a particular building, how many will glow for more than 2150 hours? How do you get it? Find the probability of a general random bulb to glow for more than 2150 hours, multiply with 5000. So this 2000 is not playing much bigger role. It is only to get the number of bulbs. If this figure is not given, what is the probability? Estimate the probability of the bulb to glow more than 2150 hours. Then it's a simple fair problem. So got the idea how to do? Copied this one. Now I'll rub that one and we'll start up the problem. If it is not getting finished, you can do it at home, right? So I hope you will be able to solve by yourself, but because it is already already placed on the board, let us settle it down. Solution. What is that solution now? What is the random variable now? You have to give the clear meaning. Let us give some symbol. Rahul, let capital X be the normal random variable. What it is denoting now? Good. I expect you to tell what is this X standing for. This X is standing for bulb. Very nice. It is standing for denoting the number of hours the random bulb burns before what? Before dying, right? No need to tell that it is this one. Next what? Given that burns in the life period. That is the life period of that. A random bulb burns in the life period of that bulb. How many hours it is living that life period, that we are denoting in hours, the capital X. Given mu is equal to 2040 and a standard deviation sigma is equal to 60. I am not mentioning the units. Hello? I am not mentioning the units. That is in hours. Okay, fine. What is that we need to do? We need to know what is the probability that the bulb glows for more than 2150. 2150 hours, that figure is X value. We need to convert it to Z value. So let Z be the Acha, you paused. Hurry, I will call it. Now, out of that 3 bits, because the question is very clear to you, I'll explain only about first bit, second bit you do it. And in the first bit, the moment I feel that you can follow, you can do it, I'll leave it. So because the time is less, other faculty is waiting. Let Z be the standard, normal, variate. Then Z is equal to, very good, X minus mu by sigma. That's number 1. Copy fast, quick. Now we need to calculate for first bit, 2150. So what is the Z value corresponding to 2150? Let us calculate. If X is 50, then Z is equal to how much it is? 1.833. Now, what is that we are calculating? That the number of hours that bulb glows lies how much? More than, or some limits given? More than. So no need of left side limit. X is more than how much? 2150. This will become probability that Z is more than 1 point. Okay, when you want the probability for Z to be more than 1.833, how is this situation? The graph will be like this. Here the point is, you want this area, but this area is not available in the table. What you need to do? You have to take the full area, 0.5 minus this area you have to remove. Okay, good, all of you. 0.5. Srinivas, you tell the value for this probability from the table.
0.4664.
0.4664. What is the final value? 8 is subtracted from 0.5. It has to be less than that one, right? 0.0336. So this is the probability that X will be more than 2150. So the number of bulbs, therefore, number of bulbs likely to burn for more than hours in a test of 2000 bulbs is equal to 2000 into 0.0336.
67, sir. Approximately 67.
Approximately you have to tell. You cannot tell that. Okay, fine. How much?
Approximately 67.
67. I hope you are clear. Because we got very less time today in the today's session, we have done only one problem. Right, okay.